Hello! Welcome back to MGTube. In this episode, we are going to demonstrate the use of the MG Chemicals Electroless copper plating process for use in activating through holes. If you are following along with the MG Chemicals professional prototyping process, this is step number 3. The purpose of this step is to apply a thin conductive layer to the inside of every through hole so we can later electroplate these holes with a normal copper electroplating process. This is called through-hole activation and is necessary because you obviously cannot plate directly to a freshly drilled hole because electroplating only adheres to conductive surfaces and a freshly drilled hole is non-conductive. In this process, we are going to expose the board to a series of chemical baths which will build up a thin layer of copper on the inside of every hole. This copper will not be thick enough to serve as the whole wall in the finished circuit. It will not carry a large current, but it will serve as an underplate. To achieve this, we need two products from MG Chemicals. We need the 41600A Electroless Copper Plating Chemical Kit and the 41600B Electroless Copper Plating Hardware Kit. The chemical kit contains enough chemicals to plate 5 5x3-inch double-sided boards or 150 square inches of copper. The hardware kit contains 5 tanks, one for every step in the process, as well as lids, gloves, a copper hang bar and hang hook, and an air pump and tube for agitating tank number 5, which requires constant agitation. More about that later. In addition to the products from MG Chemicals, you will require a magnetic stirrer. Magnetic stirrers may seem a little pricey, but we have found they are the only way to guarantee quality results with this process. The quality of the results you achieve will be determined by the quality of the fluid flow through the tiny through holes. You may try to achieve this by hand agitating, or you may try air agitation, but we have found neither of those methods will produce professional results. We recommend the use of a magnetic stirrer, and throughout the rest of this video, we will assume that everyone has one. Now, in addition to your magnetic stirrer, you obviously require a stir bar and a stir wand, and you also require some measuring cups. I recommend a 2-liter cup as well as a 500 milliliter cup. You will require a rinsing tray and a hair dryer for quickly drying your board after you have rinsed it. You will also need a timer. In addition to the kits and the hardware, you will of course require safety equipment. All of these solutions are either acidic or basic, and step number 5 contains formaldehyde, a known human carcinogen. Do not expose yourself to these vapors. Ideally, you should complete this process in a fume hood. If you do not have a fume hood available, make sure you have excellent ventilation. If you cannot achieve excellent ventilation, then use a half mask with a vapor cartridge suitable for organic and acidic vapors. In addition to considering safety, before you begin, you should consider how you plan to dispose of the chemicals once you have completed the process. Again, all of these solutions are either acids or bases and require treatment before disposal. Additionally, the final step, tank number 5, contains dissolved copper, which is lethal to aquatic life, so obviously this one cannot be poured directly down the drain. Most people do not have the skills required to treat these solutions properly before disposal, so we recommend storing each solution individually and then calling a local waste management company for pickup. When storing these solutions, make sure tank number 2 is not sealed tight because that one gases off and you will have a pressure buildup if you seal that one tight. The others, especially tank number 5, you should seal to protect people from the escaping vapors. Make sure you review the safety features of all of these products by reviewing the MSDSs available at the MG Chemicals website before you begin. Also, have these MSDSs handy to give to the waste management company. Waste management facilities can be found by calling local government hotlines or by looking at your local yellow pages. Before continuing, let's review what we achieved in the last step, drilling the through holes. When we drilled the through holes, we also drilled a hang hole in the middle of one edge of the board. Remember, if you don't want this hole in the completed prototype, you can always just cut the strip of the board off when you have completed the process. Now, when we drilled all of these holes, copper lifted up of the back side of the board. These were called burrs, and they needed to be sanded down, deburring the board. Also, copper strands were found on the insides of the holes, and these needed to be reamed out with a drill bit. The board is now perfectly smooth, and the holes are completely free of debris, and we are ready to begin the Electroless copper plating process. The Electroless copper plating process has 3 steps. Step 1 is cleaning the board. Step 2 is setting up the solutions, and step 3 is submerging the board in the solutions. Step 1, cleaning the board. Now, I'm not going to show you how to clean the board because it's quite straightforward. I will just explain it to you. You need to use an abrasive cleaner such as Comet, Ajax, or a non-chemical pumice cleaner. Use a healthy amount of water and a lot of cleaner and scrub it very well. Be aggressive, get the oxides off of the board. When the board is clean, rinse it very, very well with water. Make sure that all of the cleaner is completely removed and examine your through holes closely and make sure there is no cleaner or residue in any of the through holes. When the board is completely clean and rinsed, dry it quickly with the hair dryer to prevent corrosion. Remember, if you leave your board sitting around wet, it will corrode, and this will give you all sorts of problems later on. Now let's move on to step 2, setting up the solutions.